Hey, so welcome to our Alteryx and Grocery Retailers webinar this afternoon. My name is Sophie Harrison, and I'm a Senior Account Manager at Newcomp Analytics. I'm going to be kicking things off and then passing it over to Jordan, one of our data engineers, who is going to be doing a demo of Alteryx using a grocery retail use case. So our objective today is really to show you how Alteryx can be leveraged by retailers, and in particular, how geospatial can be used to help make business decisions. So for those of you who are unfamiliar with Newcomp Analytics, we are an end-to-end analytics provider that does software licensing, implementation services, strategic consulting, mentoring, and training for all aspects of analytics. So that's everything from analytics strategy to data warehouse development, to cloud architecture, to data engineering, to business intelligence and data science. And as an Alteryx partner, we're here to support you both for people who are considering Alteryx as well as existing clients. If you're using Alteryx on a trial basis, our job is to make sure that you have the support that you need for a guided trial. And what that means about a guided trial is that we don't just give you a trial code and you're kind of off on your own. We're here to walk you through it to make sure that you're able to accomplish the use cases that you're trying to prove out. So we have technical resources that are available for complimentary office hours to walk you through those and make sure you have a full understanding of the potential of the tool and how it fit into your role in your organization. We're here to answer any questions about the tool as well as the licenses around the tool. So after this webinar, if you are in a trial of Alteryx, we're actually able to extend it to 30 days beyond the traditional 14 days. So feel free to reach out to us for that. Or if you'd like a trial and you haven't been signed up yet, we're happy to get that started as well. For existing clients, we're here to provide you with anything from best practices advice, implementation services, staff augmentation, training, and mentoring. Our resource as a guide applies to you as well, even if you are a current client. We want to make sure that you're continuing to leverage it, you understand the new functionality, and how it can be applied maybe outside of current use cases that you're using. So at this time, what I'm going to do is I'm going to pass it over to Jordan. We're going to dive right in. We want to get right to the meat and potatoes off the bat. If you do have any questions, feel free to pose them in the chat or the questions window. We have people who are monitoring them, so we'll either address them in the chat or we'll address them at the end, whatever just makes more sense. But we'll roll with that and go from there. So Jordan, it's all yours.
Awesome, thank you so much. Okay, so I will, today we'll be walking through a couple quote unquote grocery examples. I like to think of them as kind of customer segmentation or marketing examples of how you might kind of group customers together or find out different like information about spending habits around customers using geospatial information. So in this example here, we have a few different stores. As you can see, Aurora, Colorado is the example, was the demo set I could find. And we have 400 unique customers, so all having a geospatial point and all being in kind of the same area there. So if we were to just connect to these data sources here to bring those in, I just brought in an input data tool. And as you can see, there are tons of different data sources you can connect to, be it a CSV, Excel, any kind of database that you're thinking of, so Oracle, SQL, MySQL, any kind of data source you can think of, as long as it's in a semi-structured format, even getting into the unstructured formats, you can bring that into Alteryx. So in this case, I just have an Excel sheet and a Alteryx database. And if we take a look at that, we can see we can plot these out on a map for our customers here because we have that geospatial point from census data. So we can see kind of all around the Aurora, California or Colorado area. If we were to click on different records, you can see they kind of highlight the different dots here. Find them as we click through there, so you can see it's lit up there. If we click on this one here, we can see we have a latitude and longitude, but we don't really have that same kind of map layout. We can't really see them on a map here. So the first step I would take in this example is going about creating those geospatial points. So I can go just into the spatial palette here in Alteryx and use the create points tool. That is going to automatically grab the latitude and longitude fields that were there for me. It's smart enough to pre-populate that. And if I run that now, we can still going to give me that profile, but it also now will give me that map view. We load that in there. So we can see now all the stores and highlight them on a map just like we did with the customers there. So a pretty easy way of getting our view into a map. We could export this map and leave it at that if we wanted. But in this case, I want to know of these customers, how close they are to a store, and maybe if they're within, let's say, 1 kilometer, offer them kind of like a walk-in discount, and maybe if they're within 5 kilometers, offer them a drive-in discount or something like that. So kind of create a little marketing campaign around how the customers shop. So how we would do that is we want to find the overlap within kind of that radius there. So to do so, we can use this find nearest tool and use that to measure the distance here. So I'm going to bring in the find nearest tool. Just going to delete these here. I'm actually also going to bring in just a select tool here. We use a select tool for things like renaming fields or restructuring what kind of data type it is. And I'm just going to give this a little bit more of a friendly name as opposed to cust point. I'm going to call it customer spatial, just so I know which spatial points I'm looking at. So I'm going to connect one end of that being our customers to the target. And I'm going to create our newly created geospatial points to the universe. The way I like to think about that is universe is generally going to be the bigger one that we're looking for, and the target's going to be the points within that. So if we're saying, stores and we want to find customers, I like to think of the store as the universe and the customer as the target. So as we can see here, there's going to be a find nearest configuration window. We're saying that inside of this, we want to use that customer spatial point. It's the only option. And inside of this, we want to use the centroids being the point that is our stores. We said 1 kilometer radius. We're not going to ignore those 0 matches. And if we scroll down here just all the way to the bottom, we can see there's some different fields that it's actually going to create for us. It's going to create the find nearest rank, which we actually don't need in this example, as well as a distance and a direction. And we're going to keep these fields for later on here. Okay, so we can run that, and we can see we have some matches and we have, some not matched. All of the matches here are going to get a distance in kilometers. So this is how far away they were as the crow flies, as well as a direction. Now, one of the really cool add-ons to Alteryx is dataset availabilities. You can purchase as an add-on a CAS dataset, it is called. So it is a data set that basically holds demographic information as well as drive time information provided by TomTom. So you can get into the granularity of driving, how long it takes somebody to drive during high peak times, low peak times, all those kinds of examples. As the crow flies is generally a fairly good measure, but it isn't an exact science. So if exact science is your name of the game, then the CAS dataset is definitely an add-on to look into. One of the examples I always like to use is something might be only a 1-minute walk, but if there's a large fence in the way, it can be up to a 20-minute drive to try to go around that direction. So in this case, we do have a ton of matches here. So we're going to go ahead and label these. So I'm going to just drag in a formula tool, and I'm going to create a couple new columns in our data set. I'm going to create an identifying field in case we wanted to quickly bring them up later and just call this walking. And then I'm going to create another field within this, and we can call it maybe marketing message. So we want to create a custom message for them. So what we're going to say is, you know, maybe congrats, you are within. And because we want it to be custom, we don't just want a, you know, generic message. We can add that distance in kilometers. And the way we're going to have to treat that, I'm sure as many data people will know, I'll just run this configuration here so we can look at the metadata. So we can see that this is a double. If I add a plus sign here, it's going to try to add the double here. So we need to treat it maybe as a string. So we can convert this to a string. And because it's a string, we can do string functions. That's not a very great message. It's very accurate as to how far away they are, but maybe we just want to trim that down. So let's maybe use the left 3 or 4 digits here. Let's say, let's use 4. Why not? Our nearest store. Maybe something like that. So if we run that now, oh, this should get some quotes around it there, sorry. So now we can see we've generated some custom fields down here. All these people have been identified for our walking campaign. And they all have a message here that we could automate an email for, something like that, telling them how far away they are of the store there. Okay, so now we need to deal with the next batch. We want to deal with people who are maybe within 5 kilometers and give them a drive-in discount. So we can follow that exact same process again, using the targets that didn't match and connecting it just to another find nearest tool. So we can say maybe this time 5 kilometers, exact same fields here. But this time we're going to deselect all of these tools at the bottom. We're not going to use find nearest. We're not going to measure the distance, and we are not going to give direction to it. So we can run that again. And we now see we have 320. So these people are going to be quite far away from our stores, I guess. And these are going to be, you know, our driving distance people here. But as we can see, we're missing those extra fields that were created on the other one. So just as a way of kind of showing how we can do things differently, if maybe we weren't doing a find nearest, we just wanted to measure distance, you can actually use the distance tool here and measure the distance between 2 points. So we're going to do exactly that. We'll output the distance. We can return zeros, that's all fine, everything like this, but we're going to want to change that to kilometers. We can output the direction in degrees as well as the cardinal direction. We don't need the direction in degrees, but also a very cool metric. As well as you can see here is what we were talking about earlier, some route optimized by time or by distance, if you want to get into different CAS data sets and things like that. So again, we can measure the distance here, and we can see there's our distance in kilometers as well as our direction, just like our previous example. So let's go about adding those marketing campaigns. I'm not one to really rewrite code, not that we're coding, but I'm just going to copy and paste that tool and change the fields I need here. So this is going to be driving instead. Congratulations, you're still within a distance there. Come for a driving customer discount or something like that. So again, now we run it and we can see these are all labeled driving. with our custom message. So now we could take this whole data set, union it all back together using a union tool from our join palette. This kind of stacks data on top of it, on top of each other, giving it the ability to lengthen a data set. So basically, we're going to take these 57 records and stack them on top of these 320. So some quick math there, and we get 377. So that's exactly what it's doing there. It's stacking them on top. But as we can see now, we do have our walking and driving marketing campaigns kind of mixed together here. We could pass this off to some sort of automation tool. We could have Alteryx automate sending out emails to these people. If we've captured that data, we could mail that data, anything like that. Now we are pretty set up to do a pretty cool targeted campaign. Another example, and kind of a broader example, still in the Denver area, is talking about store overlap. So overlap of stores in relation to into counties in this example. So in this case, we have, I'm just going to change the base map here, sorry. We have all of the counties within the Denver area. So again, this is an interactive map. As you scroll through the data, you can see it highlights the different segments there, and you can also click on the map. So this is Grand County, Clear Creek, kind of so on and so forth as we click around here for the objects highlighting. So again, in this example, we have a bunch of counties here. And up top, we have a list of our stores. So we have 10 stores here with latitudes and longitudes. And what we want to know about these stores is how much of each of them overlap each other, as well as overlap the county. So how much county overlap are we having? Say how much of Adams County is covered by our stores, as well as how much each store covers each county. So does store 100 cover kind of Adams County by 30%, or so on and so forth, kind of. So we want to know a very, very large, broad question. And I've done this in kind of oil and gas in the real world before, of trying to figure out kind of where's the best place to put our next station, and to get accurate pumps and things like that. So very, very useful. I've seen many examples done where hospital planning, where to put the newest hospital to serve kind of underserved areas. Again, using demographic information, really, really valuable and very, very cool examples. So off the start for this, we know we're going to have to create these geospatial points for these stores, as we only have a latitude and longitude. We don't actually have that geospatial centroid. So what I'm going to do is I'm going to use create points again to just create that point. Again, it's smart enough to pick up latitudes and longitudes automatically. And there it gives us our stores now. I really should have set this to my default map. Sorry about that. So we can see again, if we click through, this is an interactive map. We can find our different stores here. So this is down here in Aurora. And there we are in Lakewood right now. So just different stores all over the Denver area. Now we're going to say that our trade area is 25 kilometers for each store as a decent value. So I'm going to measure off that centroid. I'm going to use 25, and I'm going to say the radius is in kilometers. Now, one thing you could do is you could eliminate the overlap. So you could say if one store overlaps another store, eliminate that section. In this example, we're not going to, but it all depends on how you want to kind of cut up geospatial information. So we'll run it again. You can see we go from having a centroid, which is a point, to a centroid point and a polygon. And if we look on the map now, we will see both of those things. So we see there's our point, and around it is our polygon as we click through. So these are all our different trade areas here for each store. So you can see we do have quite a bit of overlap here. 25 kilometers is our trade area, quite a few stores in a smaller area. So now what we want to do is actually find how much this store, so let's say store 100, overlaps each of these counties. So to do so, we're going to use a spatial match tool. The way I like to think about the spatial match tool is it's kind of like a join in a way. If you come from a SQL background, it's looking for where those two overlap. So in this case, we are going to set the first one to our trade areas there. So we can set this to the spatial object of trade area because we want to find the overlap. If we were to set it to just the point, it'd be where those points end up in the county. It's not going to be very much overlap. We can use the spatial object here. We can output all of these fields here, but we're going to change this here to county object. Just so it has a bit of a better name than spatial object. They start to get a little confusing as you create many spatial points there. Okay, so let's go ahead and run this now. So as we can see, we're going to have ones that match and none don't match, which is what we would expect. We would expect that we cover every county by at least some margin, but so we can see here, it does create more records. So we go from having 10 and 18 to having 65 records. And what that's going to tell us is this store, so store 100 overlaps these following counties. I believe it was those there. So overlaps those following counties. We want to know how much it overlaps those counties by. That's kind of the real question here. And Alteryx can really help us in creating those. So what we're going to do now is bring in the spatial process tool and connect it to our match. And this is going to give us all kinds of different actions of how we want to treat the overlap. So in this case, in our spatial process, we want to look at the county object and we want to cut that from the trade area. There's a few different ways, so we could combine these. Obviously, we're looking for this little area that overlaps in 1 and 2, so we don't want to combine them. We don't want to cut the first from the second, which would leave us with just where the second does not overlap. The inverse of that would be kind of where the counties aren't covered. Creating an inverse intersection object would be kind of the inverse of what we want to do. So we do want to create an intersection object here. So it's going to take the county object, take the trade area, and create a new object where those two overlap. So I hope that makes sense. It's a little kind of geospatial-y there, but again, we're going to take the trade area, we're going to take the county object. It doesn't matter which way these are set up. And we are going to create a new spatial object that is this cutout area here. So let's run that again. And you can see we are stacking on the different polygons here, but we have a new spatial object process field there. And that is the intersection object now of these two fields. So I hope that makes sense. I know that's a little maybe out there. From there though, it's really an easy battle. We have the spatial info tool, and what it's able to do is extract information about a spatial object, such as area, centroid, bonding rectangles, which we won't get into, but as you can see, one of the things that we can pull from there is the area. So first and foremost, we're going to grab that. Let's use the county object, and we want the area in square kilometers. So if we do that, we will see we get all kinds of different areas here, and the numbers are repeating a little bit because that is measuring the area. So just as an example here, I believe I took Douglas County earlier, and I Googled the area of Douglas County on Wikipedia here. So it came back that it is 2,190 kilometers. I get 2,182.96. So I'm going to assume that they rounded probably somewhere in there, but you can see it is actually measuring the polygon object that is Douglas County. So we're getting some pretty accurate information there around sizing. The other question we obviously had is how big the overlap area is. So we're going to drag in another spatial info tool, and we're going to do that for the spatial object. And you can see we select many of these if we wanted to know different information about them, but in this case, just the area in square kilometers should do just fine. So we run that again, and that is going to give us another set of numbers there. So perfect. We kind of have all the information I think we need to answer this question. So I'm going to drag out that select tool we talked about in the first example and just get rid of some of these fields that I no longer need, no longer feel like seeing. So I'm going to keep the store ID. Probably don't need anything down to here. So I'm just going to deselect all of those highlighted fields. I'm going to take the name here and I'm going to change name to county. As we can see in the data, the name, if I can find it here, is the county. So I'm just going to give it a little bit more of an accurate title. And I don't need the key or these spatial objects anymore. I'm really just going to keep the county and the two different fields that we created here, one being the county area and one being the overlap area. So we can see now, we run that, we get a little bit more of a accurate picture of what we're looking at here. So store 100, Douglas County, there's the county's area and how much that store overlaps that county. So from there, it's a pretty simple math calculation. I think people can probably see where I'm going here. Maybe you can calculate a few different fields. I'm going to create a new one called the percent overlap. And all we're going to do there is the overlap area, divide that by the county area, and times that by 100. And we can export that as a fixed decimal, maybe with 2 points of precision, just so it makes it a bit easier to read. So there we can see how much overlap we now have. And maybe just to make it a tiny bit easier, we could sort this data descending. So we can see that clearly Broomfield County is pretty well covered. And as well as Denver County has a high percentage of overlap from this store here, as well as all these ones down here. Jefferson County kind of following next, and so on and so forth. But if we wanted to prove that out on our map here, we could take a look. Alteryx streets. So there's Broomfield County, and it's kind of just north of Denver there, in the just above the Thornton area. If we were to come over here and kind of take a look at our stores, I would assume we probably have a decent little cluster of stores in that area as well. Just let the map load in here. And there's Broomfield, you can see Thornton. So we have a store there and we have another store just south of it. So kind of proves out our point that definitely this area would not be a great place to open a new store. We would probably want to look more so down in these areas here. That are getting very small overlap numbers. Another thing I said we wanted to take our total stores trade area and compare that against how many counties we cover. So we can actually use kind of quote unquote real Alteryx tools with geospatial data too. You know, if you're more comfortable using formulas and transforms and things like that, Alteryx is smart enough to help you through that using just regular tools. So I'll show you here, we can take something like a summarize tool if we wanted to, and connect that to our trade areas. And we could actually do a spatial combine of these trade areas. So you can see we can take this trade area and do an actual spatial combine here. If I add a browse tool to that, you can see it creates one giant map of our entire store's presence. So you can see this is just one object, and if you were to compare it against probably this here, it would look like a very similar picture. Throw in streets there and zoom out a little. So you can see it's really the same picture that we're looking at. It's just overlaid and combined into one object now. So using what we learned kind of in our last example, using the spatial match tool, we could do the exact same thing with this object here. We could bring in another spatial match, connect our targets and universes again. There we go. And from there, we could do this giant name here. I'm not even gonna try to read it all out as well, and compare that against the spatial object from this one, being our counties. Kind of what we did up here with measuring and doing different processes, we can also output the intersection object within the tool itself. Something I didn't talk about, but this is where the target intersects the universe. These different options here are going to be very, very similar to the different intersections I was talking about here. All different ways of comparing different polygons. The way to think about it is really just, I put two different shapes over each other. What do I want left of those shapes? How do I want to represent those shapes? So again, we can output those intersection objects. We have our two different spatial objects here. Everything else in there looks fine. We can run that. And now you can see we have a bunch of different intersect polys. Those would be the intersections of those areas there. So like I said, we can use standard formulas and things like that to build new fields. So if we wanted to calculate, say, the counties area, we could use functions. And inside of here, you can see that there are spatial functions. So they all begin with ST. Alteryx has a really, really great autocomplete. I use it all the time. Don't be scared to use autocomplete. So as you can see, ST area is a function. It's going to ask me for an object. What object do I want to measure? Well, I want to measure the spatial combine of the county area. One thing I'm going to do, sorry to backtrack on everybody here, just how terrible this name is, I'm just going to call it county obj, just so we have a spatial object and a county object. It's much simpler, and then my code doesn't look like this when I type it out. So I'm just going to type county object. Much simpler, much easier to read. And I don't want square miles, I want square kilometers. And we can output this probably as a double. I also want to know about that overlap area. So I'm going to say overlap area. And that's going to be the exact same function, but this time we're going to use the intersect polygon. And again, that is going to be in square kilometers. And we'll set that to a double. One of my favorite things about the formula tool is you can use fields that I just created to calculate new fields. So if I wanted to calculate the percent overlap now, I could do the overlap area, divide that by the county area, and times it by 100. I'll put it as a fixed decimal again, just for ease of reading. all of those are hopefully okay now. So I'm going to go ahead and run that. We get no errors, and we get some calculated fields here. Although it does look like it calculated the same county area for all of them. That's correct. There's our overlap and our percentage overlap. I think I did something backwards here. Just getting a different result than I would expect here. So you can see this percentage overlap being 100, but I'm sure that's fine. I'm just going to reverse this calculation and see if for some reason that was it. We want the county. We want the overlap of the area in square kilometers. That is what we're calculating. Perfect. We want to divide that by the county object. And times that by 100. All right, there we go. Okay, so now we can take a select tool there, and we could drop out any fields that we don't want here. So again, we could name something like that. We could rename it. We can drop out the combine here. We can drop out our spatials, the keys. We can keep those two, as well as a percent overlap there. And when we run that, it gives us a nice report here. So we can run, and we're going to get all our fields calculated there. So Douglas County, how much overlap there is, and everything like that. So we could now take these different reports. We could throw those into a system like Tableau if we wanted to, into Power BI. We could output those into a different database if we wanted, if maybe we had a reason to store it into SQL or into Oracle to be consumed by another application. We could definitely do that. We could visualize it out into a dashboard or something like that. Really, the limits your imagination is the way I like to phrase it. If you can think of something, generally Alteryx can help you get there when it comes to data. With that, I'm not sure if there were any questions. I'm just going to go back and double check there. I see there is one question. Do we need to know C++ in order to write formulas? Absolutely not. In fact, it's quite the opposite, I would say. I am not a C++ programmer. I'm barely a Python engineer at best. It is all very, very syntactual. So looking inside of formulas here, if you wanted to learn more, you can click this FX button right here, and these are going to be all kinds of different formulas that are available to you. So if you wanted to do something around strings, maybe you wanted to know the length of a string or how to, change it to lowercase, cut different bits of it, do substrings, replace characters. All of that is available just through formulas, and if you can just click and it'll put it right out onto it for you. So very, very great autocomplete. One of your best friends will be if-else logic. If you're familiar, if there's a condition, then do an action, else kind of a catch, and then an end if. So it's definitely not C++. It's not Python. It's just very noun and verb based. So with that, I'll kind of open it up. If there's any other questions, feel free to leave them there, or feel free in the chat.
So Jordan, maybe we'll continue wrapping up and see if any other questions come in. Thanks for that presentation. I don't mind going back to the slides. We'll go over a couple more things. So in terms of the resources that we have available, as you mentioned, if you are on a trial, we're happy to extend it, or if you'd like to get set up on one, we can set you up with a 30-day trial, no problem. will help with those workflows, similar to what Jordan just showed. So if you're looking to build one specific for your organization, we can set up some office hours to help walk you through those as well. So if you don't mind going to the next slide, we'll talk a little bit more about some training options. So if you are just getting into Alteryx, we do offer a variety of different Alteryx designer and server training courses that are currently scheduled for the end of July. Of course, considering our current climate, these are all done online. So these are instructor-led online courses. So you go through exercises, you go through problems with the instructor. We were actually running these well in advance before the pandemic, so they run very well and it's very collaboratively done. So don't hesitate to take a look at these two options or these options. So these are 4 different courses. They're all 1 day long. As you can see, it kind of progresses from your core advanced predictive to your server fundamentals. So if you have any questions about these, feel free to reach out to myself, or there's the contact info on the slide, which we will be sending along. If you don't mind going to the next slide, Jordan. This is some new training that we have going on for folks on the line who are current Alteryx users. You might be aware that Alteryx released an intelligence suite. It's an add-on to the current desktop designer solution, and it really allows you to get into the intelligence analytics in a much more deeper hands-on fashion. It includes things like data text analytics as well as automated machine learning. So these are some courses that we have set aligned for that specific functionality. It's our machine learning bootcamps. We have them in 2 formats, a short and a longer version, depending on how in depth you want to go. So we'll be sending these around as well. They're scheduled for the end of the month as well. So you can take a look at these if this is something that appeals to you. All right, Jordan, if you don't mind going to the next one. We'll also be sending some information around about our analytics bootcamps. It's a great opportunity to dive into different topics that you often hear about, see on LinkedIn. Some of these are a quarter day, half day, full day, really depending on how in depth we need to get into them. But this is a great option to look into if you're looking to learn more about how these technologies work and how they apply to your individual businesses. I do believe we have a question. Sorry, so Jordan's a question. Do you have spatial data for Canada based on postal code? Jordan, I don't know if you're on mute. I'm pretty sure the answer is yes on this because I've seen it.
Thank you. As I launch in. So yeah, using that CAS data set I was talking about, you can definitely convert postal codes to, I guess they would be more so areas than geo points, because a postal code would probably be a small polygoned area, I would assume, as opposed to an actual like centroided point. There are a few different ways you can go about that depending on your use case. If you have many records to convert, definitely the CAS dataset is a fantastic way of doing that, and probably the only way I can think of in a timely fashion. If you just have a few, you can use the Google API within Alteryx to convert, I believe, 1,000 a day, but as soon as you go over that, they will kill the connection, so the workflow will fail above that.
Perfect, thanks, Jordan. I think we'll wrap it up here. We will be sending over the slides, the recording of the webinar. If you do have any other questions that come up in the meantime, feel free to reach out. You're always welcome to reply back to any of those emails or find us on our website. We're happy to help go through any of those. And if you want any examples of any of the questions that were asked, we're also happy to go through that as well. So with that, thanks everyone for the time this afternoon. I hope you found the session informational and useful. And Jordan, thanks for your time this afternoon presenting to everyone. Hope everyone has a great day.
Thank you so much. Have a great day.